Hey everyone, welcome back. Today's day 4 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way, and I've interned at Massachusetts Institute of Technology, where my area of focus was on statistics and machine learning. Currently, I rank globally on top 0.3% on LeetCode, and like most of you, I'm also preparing for FAANG interviews. So far, we have covered sliding window, two pointers, partition, and prefix and suffix patterns. Today, we are diving deep into string problems like substrings, character counts, anagrams, palindromes, and all the classic tricks interviewers love to test. Before I begin, if you find this video helpful, please drop a like, share it with your friends, and please hit that subscribe button so we can all crack this interview side by side. Let us go. So today we are tackling problem number 4, which is 647 on LeetCode, palindromic substrings. It says that we have been given a string S and we have to return the number of palindromic substrings that is present in it, okay? And the length will be bounded within 1000s as it is given in the constraint. Let us go to the dashboard and we will try to investigate and find an optimal solution to this problem. Cool. So we have been given a string S, and we have to return the count or the number of palindromic substrings that we can generate out of a given string. How do we do that? There are two ways that I would like to tell you, okay? There are two ways in which we can approach this problem, and I will just stick with one of those ways. The first way should be the brute force way, where we generate every single substring and check whether that is a palindrome or not, which will take us to a quadratic path. But again, a more optimal path would be something which is very, very clever, okay? And we will stick with that, the optimal one. Suppose I am at any arbitrary index. Let us suppose I am over here. How do I determine the number of substrings that I can generate out by standing at this index? Before that, let me give you another example. Let us just walk through this specific example, okay? We have been given a string as ABC. How many substrings we can generate such that all of them are palindrome? One of the substring will be just A, the other will be B, and the other will be C. Can we have AP as a substring that is a palindrome? And the answer is no, because A and B do not match. Similarly, we cannot have BC because B and C will not match. So we just have three different substrings in this case, that is a palindrome, and they are A, B, C, all separated with each other. Okay. How about this case? In this case, we can have A as a palindrome, this A as a palindrome, and that A as a palindrome. We can also have A as a palindrome, and we can also have A as a palindrome. We can also have A as a palindrome, right? So there are 6 palindrome here. 1, 2, 3, 4, 5, and this entire thing, 6, correct? How do we solve this problem then? Assume that I am at any specific arbitrary index. Let us suppose I'm over here. There are two cases that can happen. First case is we can have a substring of even length, or we can have a substring of odd length. Okay, cool. Let us stick with the odd length first. What happens if we have a substring of odd length? In that case, how will our pointer move? For example, let us suppose currently I have this substring and I am present at this specific index in the middle, and my both left and right pointer are present over there. Okay, how will my left and right pointer move? What we can do is we can shift left pointer one to the left and right pointer one to the right, correct? And then we can compare, hey, is left, is it equivalent to right, the value at those two indices? If that is the case, we shift L one to the left, which goes beyond the bound of the array, and right one to the right, which goes again beyond the bound of the array. In that case, we stop, okay? So what we're trying to do over here is we are trying to expurge, from the middle, one to the left and one to the array, or one to the right, okay? That is what we are doing over here in the odd case, okay? If I am at any arbitrary index, what I will do is I will try to expand myself or stretch myself to the left as well as to the right. And I'll go on stretching as long as it is possible. And when will I stop? I will stop only when if left value is not equivalent to right value. Okay. In that case, I will stop. But before that, all those substrings that we would have formed by then would be of palindrome type. And why am I telling you that? Because of this thing, right? The examples that we just went through, correct? For example, let me give you a proper example. Let me take you over here, right? For example, suppose I am this index, my left and right are present over there, right? So in this specific case, how many substrings do I have, which is a palindrome? Since left and right are at the same index and they are equal, so our count will be 1, correct? Next, what I do? I expand or stretch or expurge left to the left -1. So left will come over here and I push or increment right by right +1 and right will come over there. In that case, do we see another substring? And the answer is yes. Why? Because this is equivalent to this and this MIDI value, it is singleton. It is just independent by itself. So that is equivalent, right? So our substring will become 2 over here, count of that. And then we do what? We'll shift left 1 to the left and right 1 to the right. And since they are out of the string, so we stop and we return true for this specific case where we started from this point, the middle point. Okay, let us see if that is the case, that if we start from middle point, we will return true as the count of the substring. When I'm at middle, this is the first one, number 1. Okay, when I'm over here, so number of substring will be triple, correct? And that gives us 2. This is the first one and that is the second one, right? Because after that, left and right would have moved beyond the bound of the array, correct? And that is not something we want, and we'll stop there and thereafter when either left and right are not equal or when they break the bounds of the array. Okay, that was the case for the even case. How we are adjusting the pointer in odd case. In odd case, we are adjusting the pointer by initializing both the left and the right pointer to the iterator value itself. Okay, how about in the even case? In the even case, let us suppose my iterator is over here. And let me give you an even example. Let me say we have something like this, A, B, P, and A, okay? And let us suppose my pointer points to here currently, okay? So where will left and right go? Left will be over here and right can be over here before we start to expurge, okay? So left will be over there for even and right will be over there. And the value of left will be I and value of right will be I +1. Cool. We can also have left as I -1 and right as just I, okay? But let us go with this example. What will happen next? We'll see that these two are equal. So we'll shift left to the left by 1, and left will come over here, and right will go over there by shifting by right +1. And we see that these two are equivalent again. So we make a shift of left to the left by 1, and it escapes the bound of the array towards left. Similarly, right will escape the bound of the array towards right. And then we stop once the bound is broken, okay? So there were 2 cases that we needed to take care of. If at every time, whenever I'm at an index, there is 2 things that I do. I move the left pointer to the left and I move the right pointer to the right. But the assignment of those pointers of left and right is done for 2 different cases, for odd cases and for even cases. For odd cases, the left and right pointer will initially start from the same pointer. And for even cases, left and right pointer will start, left will start from the where the pointer is pointing to, and right will start from one place ahead of where the pointer is pointing to, right? Al is I and right is I +1. Cool. All right. So since I have explained you how these movements are getting done, let us look at the code and we'll see where it leads us to. What do I do initially? Initially, I declare a variable called as answer, which will return with a count of the total substring palindrome that we can have in the array, in the string. And as you can see, it is something that we are returning by the AND, okay? Then what I'm doing, I am scanning every single index of the string S, and this is bounded within linear time complexity, order of n. And then I'm dealing with 2 different cases, right? This is the case 1 of odd length, and afterwards we'll be seeing case 2. But for now, let us focus on odd length case, okay? So in that case, I told you the pointer will be pointing to the same index, left points to I, right points to I. And here we are checking whether those 2 pointers stays within the bound left and right. And then we're also checking whether the value that they're pointing to, whether they're equivalent or not. And if they're equivalent, and if they're within the bound, what do? I increase the count by one or answer by one, then decrease left by one, increase right by one. And I keep on doing this until and unless either of these three conditions is violated. And once that is done, I'll skip out of the loop and I'll come out of that. And then I'll deal with the if and length case where left pointer is I, right pointer is I plus one, and the conditions remain exactly the same. And these movements are also being done exactly the same. Okay. And once all of this loop is done, then I'm exhausted. We then return answer, okay, which will capture the actual count of the palindromic substring that is present, okay. So what is the time complexity in this case? The time complexity, as you can see, this one is bounded within order of n. Similarly, this will be also bounded within order of n, and this will also be bounded within order of n. So the time complexity is more or less like order of n times order of some different factor. And this factor is coming from over here. I don't want to evaluate the value of f for now. You can estimate the value of f afterwards, okay? And what is the space complexity? The space complexity is just constant because we are not taking any additional space or declaring any extra data structure apart from a single variable called as answer that we have declared over here. Okay. So yeah, that was all there was to this problem. Again, just to summarize this in a crux, okay? At every index, we have a choice. We have a choice to move. We have a compulsion choice, okay? And that choice is to shift the left to the left pointer and shift the right to the right pointer, shift the left to the left pointer and shift the right to the right pointer. And there are two cases that we need to take care of. The first is the odd length case where our substring can be of odd length supposedly, and the second case is of even length case, okay? And in those two cases, we declare and maintain our pointer as such, and the movement is done constant, like in the same manner in both those cases, okay? All right, let's go to the LeetCode dashboard and we'll try to submit the solution. I have already submitted a solution, so I'll just copy and paste my code, which is here, and I'll just run it down. And as you can see, all those test cases have been accepted. So yeah, that was all there was to this problem. It was a really interesting problem, no doubt. If you have any doubts, any questions, please feel free to ask me in the comment section. I will see you in the next one. Bye-bye.